Hi, I'm Neil, your DevOps expert. Come and ask me questions. Today's question is, I've got this wonderful Python app deployed and it runs wonderfully on my machine. How can I deploy that to the internet so that the rest of the world can enjoy my hard work? Well, here's 7 ways to deploy your Python app. And then if you stick around to the end, there's a cost comparison chart and a little flow chart to help you decide which one is right for you. So we all want smooth deployments. And in order to get smooth deployments, we need to have a plan. And a plan in code is DevOps. I know, that easy, right? But we got our Python app and we're looking at 7 different ways of how we can deploy that to the server, because there's always a server somewhere, even if we're not running it, in order for the internet to see our hard work. Number 1, bare metal. You can't get any more basic than this. Whether it's a Raspberry Pi or one of these little servers, or maybe something a bit bigger like a Dell PowerEdge server. I cut my teeth largely on HP servers, or Compaq as they were known before that. I'm really that old. Anyways, aside from taking it out of all the packaging, installing the CPUs, I know they don't come with the CPUs installed. What's that all about? And then you slide it gently into the lovely rack in the lovely air-conditioned room. You switch it on and you're greeted with a boot screen. What do you do next? Well, what it does mean is you've got full control over the hardware. You know exactly what's going in there. You want that CPU to be buzzing at the level that you want. It's yours, it's done. You want the exact amount of memory, all of it is available to your disposal. No other stuff is going to be stealing that from you. And then there's a graphics card. You want to do some Python jiggery pokery that needs a bit of CUDA CPUs, then you can put a graphics card in this, or you can put multiple graphics card in it, and you know exactly what's in there. You've got full control. It's in your data center. You could kick it if you want, maybe, if you get annoyed, but the admin is a little bit more tricky. Like I say, you get given a boot screen. It's black, it's scary, it's got text on it, and it's saying, give me a boot device. Never fear, load up a well-known operating system of your choice, whether it's Red Hat or whether it's Debian based. I'm assuming a Linux server here, of course. And then stick that on a USB, stick it in a drive, and then clicky to your heart's content, off it goes. The other way of doing it is if you've got lots of these bad boys to look after, then you might have a golden image. So it's not just going to go through the standard install, clicky, it's actually going to have an unattended file on there. It's going to install a suite of packages that you've already defined, but that's way more admin effort that's required if you've just got 1 or 2 of these servers. I mean, when I was doing that, I was deploying 20, 200 servers, even up to 1,000 servers by the time I was done. And so it's kind of handy to have that all automated. If you want to know about automation, I've got another video on that where, is it worth automating? But anyway, I digress. So we've got our Dell PowerEdge, it's booted up, it's on the USB, it's got some software on it, and now we got to the stage where we can run Ansible. Ansible is another tool, configuration management, that lets us personalize the server. And for this is our Python app. So we're going to make sure that we've got some Python installed. That'd be a great start, wouldn't it? It's then going to install a virtualizer or something, package manager, pip or Poetry or something like that. Install all the dependencies. It's going to install a web server. And then once all that's done, we can then get our thing running. Easy peasy. But the start is hard. But you do get full control. Anyway, number 2, virtual private server. I know you've probably seen them. Amazon EC2, Linode, Droplets from DigitalOcean. That kind of thing. It's a bit like the bare metal server, except you've only got a little slice of it. And you don't get that scary boot screen. I mean, you can. Some providers do give you access to the scary boot screen, but you're kind of in the same situation. They might give you an operating system to start with, so you can just SSH into that bad boy and then off you go. Of course, don't SSH into it. What you need to do is have an Ansible playbook, like I said before, and that's going to install all the good stuff for us. It's going to install Python, it's going to install the patches, it's going to install a web server, and all that kind of thing, whether it's Apache, Nginx, Unicorn, or something else of your choice. Again, we've got full access to the operating system. We can do what we want, but we're not necessarily going to have the hardware under our full control. We don't know how many other people are on the server with us, sharing the CPU and memory. We don't know whether there's a graphics card in there or not that we can utilize. Some VPSs do come with that option. And you get what you pay for. The more you spend, the bigger server you're going to get. And once you've deployed it, you've got your Ansible playbook. Happy days, server deployed. Number 3, Docker containers. Who hasn't heard of Docker containers? Well, they're very easy to run on your local machine. You have Docker, you've got a Docker file, you spin the thing up. 5 seconds later, you've got your Python app running in a Docker file. But getting that onto the cloud, that's a different matter. So it's quick to deploy, but it's a little bit trickier to monitor because we don't have access to all the other ecosystems around it. But how do we deploy it? So if you're on a VPS, then let's have 2 VPSs. Each VPS can be running Docker Compose. We can then run a Docker Compose script that says, go get our nice built Docker image from over there, and it simplifies our VPS or bare metal setup. By removing the need to install lots of dependencies, we can just chuck everything in the Docker container, and the only dependency we need to install is Docker. Easier, right? So whatever you're losing on the front end by just installing Docker means you're then sticking everything into the Docker image instead. Swings and roundabouts, somewhat easier, somewhat harder. It's your choice. We can then use a Docker Compose-like configuration in order to put it onto a hosted provider. Somewhere between, Google and AWS. Google provide Google Cloud Run, where you can provide it with a configuration for your Docker container and it will shit on lovely Google Cloud servers for you. Likewise, AWS provide ECS, Elastic Container Service, where you can too provide it with a sort of Compose-like config, and it will host your container happily there as well. Next up, serverless. Why do we need to worry about a server at all? Well, that's a very good question. So, whilst it doesn't cost much to run, where we pay on serverless only whilst the functions are running, which for our web app is probably a request comes in, we look at the things, not even a second later, we've replied with an answer. So you've paid for that tiny little snippet of time, which means if we're not getting much traffic, it's quite cheap. The cons are the scaling cost. If we're getting millions of traffic, millions of requests per second, then all those little requests suddenly add up and it ends up costing us more than if we'd bought the server ourselves. Again, we can do this on Google Cloud Run, and it'll allow you to write a function and host it on Google's cloud, or AWS come to the rescue with Lambda, which is where, again, we just have the thing in a special zip file, and we can upload that to Lambda, and it will then run if we ask it nicely. So you think you're going to get away with not worrying about anything else but the server? True, we don't have to look after the server, but we need a lot of other infrastructure instead. So AWS will provide us with the API gateway, which will take in our request, pass it on to the function does its thing, replies back to the gateway, and that goes back to our customer. So we need this other extra bit in order to trigger our function and handle the request and the response. A bit like a web server, maybe. Of course, if you need anything more than that, it can get even more complicated. The gateway could go to the Lambda, that then goes to a VPC endpoint, and it goes to a database. So I have not mentioned databases at all yet, have I? That's another complication altogether. But if you're running a Python app that requires some storage, then you might need a database at some point. All the options above, you can install a database. When you get to the service level, it's going to be an add-on service. Number 5, platform as a service. Heroku gives you a very easy way of deploying your application. You give it a Git repository, you've got some special config in there, and it installs it for you and gives you a server address. Hey ho, happy days, minimal effort on your part, and there it is. And there are a couple of other companies that do a similar thing. There's Railway and there's Render. Both look different, both do things slightly differently, and both have simpler payment plans. And as a platform as a service, they will then give you the extra add-ons. You want that database? Sure, just add it on. You want more CPU? Sure, just add it on. And the costs can quickly scale up, but they can scale with you. You can start off very small, you can end up very large. Again, at the larger end, you're probably better off looking at the VPS or the bare metal option, but we'll get onto those choices later. Managed Kubernetes. So if you've got a lot of microservices to look after, we're not talking about one app anymore, we're talking about 10, 20 of them all working together, then we might need to look at something like a Docker cluster. One way of doing a Docker cluster is managed Kubernetes. Kubernetes is not the only way of doing this, and I've got another video that says here's the Kubernetes alternatives, and I'll put the link to that below. Just to touch on the alternatives, we've got EKS, Google KS, we even got AKS, depending on whether you're Microsoft flavored, EC2 flavored, or Amazon flavored. They're all pretty much the same. They all bill slightly differently, and whichever one you go with is probably makes sense that you have the most knowledge with, or you've got other services in there already. If we're talking at this level, then that's a lot of services. You've probably got a team that can support you with that decision. And to deploy it, you can use a number of different ways of deploying it as well. There's Helm charts, and there's other definitions that you can use. But it will cost you a significant chunk of money. There's almost a stupid tax on it. But it does provide you a lot of functionality on the back end. And number 7, a hybrid approach. So we can combine a couple of these strategies in order to be really strong with our approach. We can have something running on an EC2 machine that will give us a baseline amount of CPU compute, and it's relatively cheap compared to Lambda. We can then tie that to Lambda to deal with our peaks when we're really busy. And by mixing the two together, we kind of get a blend of a cheap base cost and a slightly more expensive peaky cost in order to work with our traffic flows if it's not really flat and predictable. So which one is right for you? Well, I've attached a decision flow chart below, and that will go through the options. Do you need full control over the hardware? Do you have a support team helping you? Do you have multiple containers or just one to look after? Have a look at the flowchart and let me know in the comments below if you found it useful. I've also included a cost comparison chart. The cost comparison will give you the upfront basic costs of something of an average server that can host more than one server, or one container rather, but it will give you a clue. Have a look at that. Again, if you want any feedback on that, ask me a question below, or you can come along and ask me questions at my circle. It's on www.techanswers.club. There's an invite link below, and I'd look forward to seeing you there. Anything else I can help you with? Ask me a question, come along, and I'll see you in the next video.